Hello and welcome back to All Automation Professionals. In this episode, we're going to expand on what we've done in the previous one, and I'm going to show you how to create the ladder logic implementation for controlling our machining center inside of Factory IO on the Allen Bradley RSLogix 5000 or Studio 5000 based PLC. So without any further delay, let's get started. So just as a quick recap, what we can do at this point is we can play the animation and we can start the machining center by pressing the start push button on the controller, which then allows us to process the raw materials. In order to send in the raw materials, I need to force this conveyor belt, which when forced will send in the raw material into my machining center. And as I said, as soon as I press the start button with the material inside of the cell, the robot is then going to process that and create either a base or a lid, depending on the selection that we have inside of the machining center. So our goal here today is to complete this production line by adding the discharge conveyor, but also adding a control system that will use the tags that we have available to control this and automate the process both on the conveyors as well as the robot. So what you'll see is that I need to be the operator that presses the start push button once again, and we obviously want to avoid having a person in front of this machine to make it running. So we're going to create a panel inside of Factory IO, tie the tags back to our PLC, create the ladder logic structure that we need to get this done, and then test everything at the end of this video so that I can show you that it works as expected. So what I've done here is I've added a control panel with a couple of push buttons as well as a conveyor leading out of the machining center. My goal is to also label these accordingly so that we can very easily identify what's going on, because now we're starting to have a lot of components inside of Factory IO. So in this case, this is my machining center setup, and this is going to be MC discharge conveyor. And this is important because inside of my driver, I'm going to have to drag out these tags. And so if I don't have the right labels, it's going to be very confusing if it's just going to become start push button 3, start push button 4. So I need to be really clear on what's going on here. So in this case, instead of having start button 2, I'm going to rename this to MC start push button. So I know that this is in reference to my machining center. I'm going to do the same thing on the stop. So MC dash stop PB. And the other item that I want to explain really quickly, so I have a toggle switch. If I press play, what I can do in Factory IO is drag it from 0 to 1. As you can see, there's going to be two different states that I can monitor, so state 0 as well as state 1. And the idea here is, just like you would see in normal production, be able to toggle between two modes. So the idea here is that, again, our robot or our machining center can produce either lids or it can produce bases. So those are the two items that the CNC can make for us. And so the toggle switch is going to allow us to manually select what we're producing. But the logic behind that is that the PLC is going to receive the toggle switch input, and then it's going to send an output to the machining center in order to select the right part. So there's going to be a couple of things that we need to program in order to ensure that this works correctly. Inside of my drivers file, I need to accomplish a couple of things. So the most obvious ones, I need to have a start push button. I need to have a stop push button. So those are going to be the inputs for me to start and stop the production line. As I've mentioned, I also want to bring in the selector switch. So I'm going to bring in state 0 as well as state 1. I also want to look at the statuses of my machining center. So this can be a little bit more complicated in the real world because you're going to have different faults from the robot. You're going to have different states. In this case, we're not concerned with the state yet, but obviously if you're looking for a greater challenge than what I'm showing you here today, make sure to bring them in and process them accordingly. Again, you can read the documentation for Factory IO to fully understand what is this has error, when is the progress enabled, when is busy enabled, when is open enabled, so you can create more advanced logic than what I'm going to show you here. That being said, on the output side, so we need to find, once again, the machining center, and first we have the infeed conveyor. Next, we have the discharge conveyor. So we need to actuate the motors or the variable frequency drives that drive both of those conveyors in order to bring raw materials in, as well as retrieve the finished goods. But we also need to make sure that we can toggle the start button of the machining center. So remember that we want to eliminate the need for an operator to always click that start push button. So we need to be able to actuate that for the machining center. And the last item that we need not to forget is going to be the produce lids bit. So once again, this is something that can be toggled or forced inside of factory IO, but we need to be able to toggle that via the switch through ladder logic inside of our controller. So I'm going to connect to the controller. So once I go online, this is a check for me to see which tags have been created and which have not been created. And you'll notice that next to the many tags, actually all of them, I have this does not exist label. So I need to go back into RSLogix or Studio 5000 and make sure that I create these tags so that we can start programming the logic for our machining center. And so this starts by input 11 and this starts by output 9. And I need 4 on either side, so simply counting down the tags. You can obviously pre-create a lot more of them if you want to have a future expansion possibility, but in this case, I'm going to focus on just 4 of them. So let's switch into Studio 5000. We need to go into controller tags, and I can just very briefly review what I already have used inside of my controller. So you'll notice that the current list ends at input 10 when it comes to Boolean. So I can simply copy that name so I don't have to remember or memorize what it has been, because it needs to match down to the letter in order to work. And I can go into my edit tags, type in 11. I need to change the data type to bool. So remember, very important, otherwise this is not going to work. And I can simply create 4 of those tags in sequence. So we have tag number 12, 13. All of these are going to be Boolean, very important. Otherwise, as I've mentioned, that's not going to work. And I need to give these tags a description. So again, I had tags inside of Factory IO. I want to make sure that when I'm programming on my PLC, I have the right labels. Otherwise, it can get very confusing. So this is going to be machining center, and this is going to be start push button, or PB for short. I'm going to copy this and go to my stop push button. So this doesn't copy really well. I'm not exactly sure why. So I can right click, make sure that I copy. And let's see here, right click, paste. So this is going to be my stop push button. Next, I have the toggle switch, MC toggle position 0. And I'm going to copy this as well. So copy. And I'm going to have MC position 1. So those are going to be the 4 inputs really that I have inside of my system. Next, I have the outputs. So in this case, it ends at B output 8. So I need to get 4 outputs inside of my controller. So that's going to be 9. Once again, that's going to be a Boolean. And we're going to create all of those in sequence. And so obviously I want to, again, double check what kind of inputs and outputs I have by looking at Factory IO really quickly. So I have infeed, discharge, then I have the machining center start, and then I have produce lids. So I want to label this again very descriptively. So this is going to be in feed conveyor run. I'm going to right click, copy this, make sure that I paste this in. So this is going to be discharge conveyor run. Obviously, this is the machining center. So this I'm going to call something differently. So robot cell / CNC run. And then I can also put in here. So this is going to be machining center produce. And I believe that when it's energized, it's going to be lids. When it's de-energized, it's going to be bases. So you can get as descriptive as you want, but in this case, I'm going to say lids, which means that if it's energized, it should make lids. But again, we can troubleshoot that a little bit later. It doesn't need to stop us from creating the logic. So we have the tags in place. I want to select the first tag. Actually, let's go look at the logic first. So inside of Factory IO Sim, this is something we've been working on in many lectures. You'll see there's going to be many rungs. If you want to reference back, we're doing an entire series on Factory IO, Allen Bradley RSLogix / Studio 5000 programming. So what I'm going to start with is a very common scheme in PLC and systems programming. which is going to be a latch of my running system bit. So that's going to be a start push button, a stop push button, as well as a system running. I'm going to scroll all the way down. So I'm going to paste that rung in. I use the shortcut Control C, Control V to paste that. I'm going to also use the shortcut Control D in order to add a comment to my rung. So here I'm going to say machining center logic start. And that's going to be an indicator for me that from this point forward, this is going to be logic that controls the machining center. But remember, we still need to change these tags. These are going to be incorrect. So I'm going to see what's going on. So input 10, I believe it's input 11 that we had. So motion or machining center input 11 is going to be the start push button. This is going to be the stop push button, which is going to be 12. I need a tag that allows me to see that the status is running. So this is going to be machine running. I've already created this Boolean in the past, so we can leave that as such. And I'm going to paste that in as the status indicator. So the machining center is running through the use of the start and stop push buttons. I can confirm this logic since I'm not going to make any other changes to this rung. Based on the line running bit, I want to be able to start both conveyors as well as the machining center. So I'm going to create another rung right underneath, and I'm going to use the same MC_running tag in order to enable those three items. And here's a quick tricky question for you that I've used in interviews. If you have 3 OTE instructions, doesn't matter if they are going to be in series or should you be placing them as a branch? So I'm going to quickly illustrate this question. So you can have 3 of these OTEs right underneath each other, and that's going to be the last third one. Is there a difference in how the code is going to be executed? And in this specific scenario, that's not going to be a difference, right? Because there's not going to be a condition in front of any of these OTE instructions. So it's going to execute the first one here, then the second one, then the third one, or if they were lined up in series, then it's going to be the first, the second, and the third one. That being said, if I'm asking this question of an automation engineer or technician, I would expect them to mention that nuance. I would say, well, what if I add a condition here versus if I add a condition in series? And in that case, it's going to be different because here the condition is only going to impact this branch, while if it is in series, it's going to impact everything that is set after it. But in any case, that's going to be a little trivia for you guys. I want to go back to the controller scope tags just to double check what we have. And in this case, it's going to be the infeed conveyor, the discharge conveyor, as well as the robot cell, so tags 9, 10, and 11. And I'm simply going to paste that in. So 9, 10, and then 11. So at this point, we should be able to run the conveyors as well as the machining center. And what I want to do is I want to test the logic at this point before we do the toggle, because this is a key component of what's going to allow me to run that cell and actually make finished goods on my plant floor. So let's switch back into factory IO. I'm going to disconnect and I'm going to reconnect my controller to make sure that all the tags that I've created are now no longer displaying that error. I'm going to go back to my scene. I'm going to press play. And remember that my idea here is that I need to press the start push button in order to enable the conveyors as well as the machining center. It looks like we have raw materials coming in. It looks like the robot is going to automatically pick up that plate without me having to press the start push button. It should process it inside of the CNC. It should then place that on the discharge conveyor, which is going to bring the finished product onto the floor at this point. But the robot should repeat the sequence without me having to press that start push button, or without me having to have an operator that presses that start push button. So in other words, we are continuously creating one product at a time. And this is going to be the optimal throughput of the cell. As soon as the product is finished, the robot goes back to the position. It's going to take the next raw material and then produce the same part. So everything works here. Obviously, the toggle doesn't do anything since we haven't created the logic for it. So let's do that right now. So here's another little trap for automation professionals that are just getting started in controls, which is going to be using the OTL and OTU instructions inside of your PLC. So one of the most obvious ways that we could program this is we have two inputs and we're toggling one single output. So the common sense dictates that I can create two rungs. And on the first rung, I will say that if the toggle position is in 0, I'm going to latch in lids. And if the toggle position is in position 1, I'm going to untoggle or unlatch the lid. So let me just demonstrate that really quickly. So in this case, I believe we are using input number 13. Let's just double check. So toggle position 0, I can simply say let's latch the lids, and that's going to be output number 12. Let's see here, so 12, and I'm going to change that to an OTL. And here I'm going to create a second rung, so this is going to be 14. Press on enter, and this is going to be an unlatch of this bit. And so this is logic that's going to work. So I just want to demonstrate this for learning purposes. So we can paste this in, say yes, and we can go back to factory IO, and I'm going to show you how I can toggle this bit now and be able to do exactly what we've designed. So press play. I'm going to monitor a couple of tags. So this is going to be my state 0, state 1. I also wanted to monitor the lids. So I'm going to use this little trick. I'm going to go on the conveyor, produce lids. And if I toggle the switch, you'll notice that the produce lids is definitely toggling from 0 to 1. And obviously, this is going to accomplish exactly what we've set out to do. So what is the problem with this? And let me explain to you what could happen. So if I stop the machine again, if I go back into my Studio 5000, well, at this point, you've left a somewhat of a loose end where if I'm a programmer that comes in after you, I might look at this logic and I may want to create a rung that's going to do something different with either these tags or some other functionality. So in this case, I could say, well, I have some weird condition where the machine needs to produce lids based on, let's say, a SCADA system that we've deployed. And so I'm going to add logic here that says SCADA underscore produce lids, right? And so this is going to force my tag. And as an example, it's going to unlatch my tag. Right, and so I'm going to create this new SCADA produce lids tags inside of my tutorials. Press on create. I'm going to paste this in. I'm going to press on yes. And obviously what you will see happening here is that if it's not enabled, then the logic works as expected because the machine is getting the right bit. But as soon as I toggle this on, you'll notice that we have a conflict where this tag is enabling and this tag is disabling. So you have two systems that are fighting over the control of a single tag. And in this case, just because the SCADA produce lids is after the toggle position 0 selector switch, it's going to completely eliminate the function of what has been designed in your logic. So how can we remedy this? Well, the general piece of advice that I give all engineers that program control systems is that you should not be using latches and unlatches because it can lead to this situation. So how can we do this with an OTE? And simply put, we can use one of the toggles based on the position in order to toggle the OTE. So what I'm going to show you here is I'm going to delete both of these rungs, and I'm also going to modify this rung to say that if it's in toggle 0, I want to energize the produce bit or the produce lids bit. And what this is going to do is it's going to automatically, if it's not in that position, it's simply going to de-energize the produce lid selection. And so let's just double check that this works. So again, we have this downloaded. I'm going to go into factory IO. I'm going to press play. As you can see, I'm in position 0. If I switch to 1, my machining center produce lids is disabled. If it goes back to 0, it is enabled. So essentially, I'm only using one state in order to enable produce lids. And it accomplishes the exact same function that I've shown you using the OTL and OTUs, but it avoids the problem that I've described, which is at this point, if you wanted to do something with the SCADA, you would have to put that in line with the logic, and thus you need to make a conscious decision of what this is going to do. So in short, the conclusion is that you should be prioritizing using OTE instructions over OTL and OTU. And again, there's going to be a lot of examples that we can use to prove how difficult it might be when you have a lot of OTLs and OTUs. But we have terminated the current lecture, so I wanted to go back into Factory IO and see if we can simulate the entire production and produce both products. So I'm going to press play. We've already started the system, so it should technically start as soon as materials come in. We're going to produce first, let's see if it's going to be lids, and then we're going to toggle our switch and hopefully produce bases. And so, as I had mentioned in the past, you can certainly make this process a little bit more complex, and we're going to look at this in maybe next tutorials. Let me know if this is something you're interested in, maybe what kind of complex problems you would like me to solve. That being said, in this case, we have a lid, so the robot is going to repeat that operation. While it's doing that, I'm going to shift the position of my selector switch to state 1, which is going to de-energize that bit, and hopefully on the next cycle, the robot should produce the other component that we're looking for. So you'll notice that there's going to be a difference of these components. I can drag this around, so that's going to be a lid. And hopefully that the next component that we receive is going to be a base. And that is exactly what I was describing. So this is going to be a base that's going to come in on top of, or I guess at the bottom of the lid. But in this case, hopefully it falls flat. And as you can see, again, this is something that we'll need to create an assembly process for. But ultimately, both of those items can go together and create one finished product. In any case, that's all I have for you today. If you have any questions on how to program these systems, make sure to leave them down in the comments. More than happy to answer them, and I'll see you in the next lecture.